All right, we're looking at differentiation. We have two diagrams on the board. This is a linear function, and this is a quadratic function. Now, what do we do with this differentiation? Differentiation is simply a change in one parameter with respect to the other. We use this differentiation to find the gradient of a function. We use the differentiation to find the gradient of a function. Usually, people describe it as the y dx, the change in y-axis as a result of change in the x-axis. Now, if you have a straight line like this, and we want to look for the gradient of this straight line, usually the gradient is the change, that's change in the vertical axis, which is something of this nature, change in the vertical axis. Let's say this is going to be y1, up here is y2. This point is x1, and here is x2. So we call it the gradient. The gradient, another name for the gradient is slope. Gradient or the slope is the same thing as the y, the x, and that is going to give us y2 minus y1 all over x2 minus x1. Now, in a straight line, the gradient at any point on that line is the same. So if I'm taking my gradient here, I'm taking the gradient here, whatever value I'm going to have is going to be the same, even if I decide to draw my line like this. So anything I'm having is going to be the same because the gradient of a straight line is constant. The gradient of a straight line or we call it a linear function is constant. Is constant. Please take note of that. It's constant. The gradient is constant. So if you look at this particular straight line graph, it is an accelerating straight line graph. You see the way it is going is accelerating. So the gradient of this is positive. The gradient of this is positive. The gradient of an accelerating graph of this nature is positive. So the graph is accelerating. In this case, the gradient of this, the y, the x, is going to be positive. But if we have a situation like this, if we have something like this, let's look at this. If the graph is like this, it's coming this way. This is a retarding linear function. It's a retarding linear function. So the y dx of this function, the y dx of this function is negative. As a result, is negative. So if you differentiate that, it's going to be negative. So you can see from the explanation I've given here how to get the gradient of a straight line or a linear function, which is change in the vertical axis all over change in the horizontal axis. That's change in y over change in x. So if we look at the quadratic function, this is a curve, a quadratic function. You discover that in a curve, the point keep changing face. The point keep changing face. The point keep changing face. In this case here, if we were to look for the gradient of a curve, the gradient is not constant because the curve is changing face at different points. So we we can't say the gradient of a curve is constant because it keeps changing. If you look at the curve from this way, you find out that the curve is actually decelerating like this from this point, and this way the curve is accelerating up here. But at this way, which is the turning point, the curve is a bit, at this point here is a straight line. That point, the curve is a bit stable. And that is to say that the gradient of all this, the gradient of this side is going to be different from the gradient of this side. It's going to be different from the gradient of this side. Here at this point is the turning point. Here at this point, the gradient here at this point here, since it's decelerating, the y, the x here will be negative. The y, the x here will be negative. At this point, the y, the x is going to be positive because it's accelerating. At this point here, which is the turning point, the y, the x is going to be 0. So the gradient at that point, the y, the x is going to be 0. So if we similarly, if we have a curve like this, if we have the curve like this, it's coming this way. You find out at this point here, this phase, the curve is accelerating here. There's the turning point, and the curve is decelerating here. So at this point here, the y, the x is going to be positive. At this point, the y, the x is going to be 0. At this point, the y, the x is going to be negative. It's going to be negative. Now we recall that the standard form of a quadratic function is given as y equal to ax squared plus bx plus c. The c is the intercept where the curve is touching the y-axis. That's the c. Is the intercept where the curve is touching the y-axis. So at this point here, this is the c where the curve is touching the y-axis. We also have other functions, polynomial functions. We also have other ones like this. It's a polynomial function of the third degree. And we also have something like this. Also a polynomial function of the third degree. All right, so we'll move quickly into how to differentiate a function. If we have a function, for example, let's take a linear function as in y equal, we're looking at the linear function now. Linear function. So y equal to, let's take y equal to 2x. And we are differentiating a function of this nature. The formula for differentiation is given as, if you have a function like this, y equal to x raised to power n, let's say let's say ax raised to power n, where a is the coefficient of x and n is the power of x. So to differentiate this function is given as, we differentiate this function by multiplying the power by the coefficient and subtract 1 from the power. So from this, the y dx is going to be n times a. So it's going to be n times a x raised to power n minus 1. So we are going to have a n x raised to power n minus 1. So that is the formula for differentiation. So if we apply this formula to what we have here, we now discover that the y dx of the function up there, the y dx of this function here, the coefficient of x is 2, the power of x is 1. So we're going to multiply 1 times 2. So it's going to be 1 times 2, x raised to power, the power is 1, we're going to subtract 1 from it. So we're going to have 1 times 2 will give us 2, and 1 minus 1 is going to give us 0. So x raised to power 0 is going to give us 1. So x raised to power 0, recall x raised to power 0 is 1. Therefore, we are going to have this as 2 times 1. That's going to give us 2, and that is the answer to that particular question. That's the answer to that particular question. I take another example. Let's look at y equal to, let's take 3x plus 2. We are differentiating this. This is going to give us the y dx. It's going to give us, if we differentiate this is going to be 1 times 3 will give us 3. And if we subtract this, it's going to give us x raised to power 0. When you differentiate a constant is the one that has nothing to do with the variable. If you look at 2, 2 is a constant. When you differentiate a constant, the result is 0. So this is going to give me plus 0, and this will give me 3, because x raised to power 0 is 1. So the y dx of this function is going to be 3. So take note of that. When you differentiate a constant, the result is equal to 0. So just take a note of this. When you differentiate a constant, the result is equal to 0. Is equal to 0. So we have the y. So when we differentiate a constant, the result is going to be 0, where k is a constant. When you differentiate a constant, the result is going to be 0. All right, I'm going to clean this part of the board. Just introducing you to differentiation. So what if you have a function like this? Y equal to so that's for a linear function. I'm going to take off this as well. So we're going to look at some questions on the board. Going to be mixed, both linear function and functions that are not linear as well. So let's look at this example. We'll take question 1. We're going to look at 3x plus okay, let's look at it this way. 2 minus 3x. 2 minus 3x. We take question 2. Y equal to 1 all over x. Question 3. Y is equal to x squared plus 3x plus 2. And question number 4. Y equal to x raised to power 3 plus 2x raised to power 2 plus 4x minus 2. So we're going to look at these 4 questions on the board. I'll start with the first one. First one, which is a linear function, question number 1, y equal to 2 minus 3x. So I'll differentiate the y, the x of this function is going, if you differentiate a constant, I told you is going to be 0. This is a constant, so that will give us 0 minus, if we differentiate minus 3x, from what I explained there, we're going to have minus 3. So this is going to give us the y dx is going to be minus 3. That's for the first one. So we move to the second question. We move to the second question. We now move to the second question. The second question is y equal to 1 over x. And this, from our law of indices, can be written like this. So we now have the y dx of this function. The power here is minus 1. The coefficient is 1. So minus 1 times 1, that will give us minus 1. So we now subtract 1 from the power. This will now be minus 1 minus 1, and that will give us minus x raised to power minus 2. So we now have this, and this can be written like this over x squared. When we follow our law of indices that states that if you have x raised to power minus 1 is the same thing as 1 all over x. So that's for question number 2. We move down to question number 3. This is for number 2. Move down to question number 3. Question number 3. We have y equal to 1 over x. No, question number 3 is not that. That's for question number 2. So we go to question number 3. So y equal to x squared plus 3x plus 2. That's question number 3. So we are differentiating this. So it's going to be the y, the x. When you differentiate x raised to power 2, we're going to have 2x. When you differentiate 3x, it's going to give us 3. And when you differentiate 2, it's going to give us 0. So this is plus 0. So hence the y dx is equal to 2x plus 3 as the answer to that question. 2x plus 3. So I'm going to look at the fourth question. I'm taking off this. I'm looking at the fourth question. I'm going to take my time to explain the fourth question again. Look at the fourth question. This is what we are solving. Y is equal to x raised to power 3 plus 2x squared plus 4x minus 2. So we're going to have the y, the x of this. This is 3x raised to power 3. So you're going to multiply the coefficient of x. The coefficient here is 1. So you're going to multiply 3 times 1. So 3 times 1 will give us 3. X, we subtract 1 from the power. That will give us 2. This is going to be 2 times 2, 4. We subtract 1 from the power, is going to give us x raised to power 1. This is going to be 1 times 4, which is 4. Subtract 1 from the power is going to give us 0. So when we differentiate the constant, it will be 0. So we can as well leave the 0 out of it, since it's not going to make any significant difference. So this is going to give us 3x squared plus 4x. Now recall that x raised to power 0 is 1. 1 times 4 will give us what? 4. So the y dx is going to be 3x squared plus 4x plus 4. 3x squared plus 4x plus 4. That is the y dx of the fourth question. That's the y dx of the fourth question. Okay, I'm going to do one example now. I'm going to do one example. Before I'm going to introduce you to other ways of differentiating a particular function, because transit functions are very straightforward functions that might not be this straightforward. So if you're solving questions like this, you have to use the techniques in differentiation that I'm going to introduce to you very soon. So I'm looking at this question. Let's look at this. Y equal to 1 over square root of x. We have a question like this on the board: y equal to 1 over square root of x. So for us to solve this question, we're going to look at it like this to make it easier. Square root, it means when you're raising the power to 1 over 2. That's the meaning of square root, raising the power to 1 over 2 from the law of indices. So now the power here is 1 over 2. So this can go up and it will now change to minus 1 over 2. So x raised to the power minus 1 over 2 as the power. So we can differentiate this now. The y dx of this function is going to give us, the power is minus 2, the coefficient here is 1. Minus 2 times 1 will give us the power is minus 1 over 2, and the coefficient here is 1. So we're going to multiply minus 1 over 2 times 1. Minus 1 over 2 times 1 is going to give us minus 1 over 2 x. So when we subtract 1 from